Hello and welcome back. Today we're going to learn how to construct and employ what are called XY chains. These are chains made up exclusively of bi-value cells. XY chains are simply longer versions of XY wings that we learned about in tutorial number 23. An XY wing is constructed with only 3 bi-value cells, but with an XY chain, there is no limit to the number of bi-value cells you can use as long as you link them together correctly. So let's go over to the puzzle board and see how this works. I touched on XY chains for a moment in video number 18 on bi-value cells. So if you saw and understood that, you will have a head start on today's lesson. As we know, all chains in Sudoku are made by alternating the links, strong, weak, or weak, strong, etc. This is what is meant by the term alternate inference chain, or AIC. An XY chain is simply an AIC made up entirely of bi-value cells. There is a strong link between the two candidates in any bi-value cell. They are strongly linked because one of them has to be true. If one is false, the other is true. This is the formal definition of a strong link. If A is false, then B is true. And because of that strong link within the cell, bi-value cells can be linked together by using weak links between the cells. And because a strong link has the properties of a weak link, this means we can use any valid link to connect the bi-value cells. And this fact comes in very handy and gives us lots of options to construct a chain. It is called an XY chain because just like in algebra, X and Y are unknowns and they just refer to any two candidates. With an XY chain, the bi-value cells do not have to be identical, i.e. they do not have to contain the same 2 digits. They can all be different pairs of candidates. There are only 2 stipulations. The first stipulation is that in order to connect any 2 bi-value cells, they must share at least one common candidate that you can link together with a weak link or a surrogate weak link. If you have watched all my tutorials, you know that when we use a strong link as a weak link, I like to call it a surrogate weak link to differentiate it from a conventional weak link. And the second stipulation is that the 2 bi-value cells must see each other, i.e. they must both lie in the same house. And further, in order to gain any benefit from the chain, it must begin and end with the same digit candidate, and it must start and end with a strong link. These are simply the rules for an AIC Type I. And when this is the case, it means that at least one of those same digit endpoint candidates must be true, which allows us to eliminate any other same digit candidate that can see both endpoints, just like we do with so many other solving techniques. Let me show you what I mean. All right, here we have an XY chain made up of 4 bi-value cells. And remember, the strong links will be within the cells and the weak links will be between the cells. So let's start on this one up here in row 1, and that'll be our first endpoint. And that's a strong link, then a weak link to that 9, a strong to the 2, weak to the 2, strong to the 8, weak to the 8, and finally a strong to the 1. So the 2 endpoint cells are here, and there are 2 cells that can see both of those cells, and one is here and one is here. So if they contained a 1, they would both be false because the 1s are the endpoints of our XY chain. So now let's draw the chain. We have strong, weak, strong, weak, strong, weak, and finally strong. So the most important thing to remember is that any endpoint of an XY chain is always going to be the other candidate from the one that is weakly linked to another bi-value cell. Okay? The candidates that are used to make the weak links between the cells cannot be the endpoints of the XY chain. Now with an X chain, because there are sometimes strong links between the cells, that restricts the number of possible candidate eliminations as I demonstrated in the previous lesson. But with an XY chain, because all the links between the cells are always weak links, this restriction does not apply. So when the endpoints lie in different chutes, like you see here, you can have up to 2 possible eliminations. And when the endpoints are in the same chute but not in the same house, you can have up to 6 eliminations like this. All right, here in this diagram, we have an XY chain made up of 5 by-value cells. And remember, this is an AIC Type I, so it's always going to have an odd number of links, but there can be any number of by-value cells. It can be odd or even, because there will always be one more strong link than there are weak links. All right, so let's start on this 3 up in row 1, and that's a strong link to the 7, a weak to that 7, strong to the 2, weak to the 2, strong to the 9, weak to the 9, strong to the 4, weak to the 4, and finally strong to the 3. So here are the 2 endpoint cells, and those 3s are the 2 endpoints of the chain. And they both lie in the same chute, so there are 6 cells that can see both of those 3s. And that means if there was a 3 in any one of those 6 cells, they could be eliminated as false. So once again, let's draw the chain. We have strong, weak, strong, weak, strong, weak, strong, weak, strong. Everyone see that? All right, so now let's see what happens when the endpoints lie in the same house. Now, once again, we have an XY chain that's composed of 5 by-value cells. And as you're going to see in a minute, we can actually start on any one of these cells, but let's start on this 7 up here in row 2. So that's a strong link to the 6, a weak to that 6, strong to the 9, weak to the 9, strong to the 1, weak to the 1, strong to the 5, weak to the 5, and strong to the 7. So those 2 7s are the endpoints of our chain, and let's draw the chain. We have strong, weak. Now when I am drawing these chains, I will use green arrows for the weak links and blue arrows for the strong links, as I always do. But since all the strong links in an XY chain are within the cells, I will draw the strong link if there is room, but if the 2 candidates are too close together, like this 6 and this 9, I will just leave it blank, and you will know that the strong link is implied because you will see 2 green arrows coming in and out of the cell on either side, okay? So now we have a strong link to that 9, but then a weak link to this 9, and then a strong link to the 1, a weak link down to this 1, and then a strong link to that 5, and then a weak link to this 5, and finally a strong link to that 7. So those 2 7s are the endpoints of the chain, and that means any other 7 that can see both of those is going to be false, and that means there could be a 7 in every other one of those cells in column 4, and they would be false. Now I'm going to have to get rid of those arrows to make this next point. But if there were a 7 here, or here, or here, or here, or here, or here, or here, they would all be false. But look what's happening here. There is a weak link between those 2 7s, so this turns out to be a continuous loop like we saw in the last video. There are 10 candidates and 10 links, an even number of candidates and an even number of links, and they loop back exactly to where they start in a perfect fashion. So that means every weak link becomes a strong link. Here, let me draw the chain one more time. All right, first let's get rid of these red 7s. All right, so here is the original chain, and if you notice, there is a weak link back to this first 7. Okay, so now that is a continuous loop. And what's happening here is you could remove any one of those green arrows, and the 2 candidates that are left free, like for instance in row 7, if you eliminated this weak link between the 2 5s, those 2 5s would be the endpoints of another XY chain, and that means you could eliminate any other 5 from row 7. And likewise, if you remove the weak link between the 2 1s in column 7, those two ones would be the endpoints of an XY chain, and you could eliminate all the ones from the rest of column 7. And within block 3, that weak link between the two 9s, if you remove that, you could eliminate every other candidate 9 from the rest of block 3. And the weak link between the two 6s in row 2, if you eliminated that weak link, then those two 6s would be the endpoints of an XY chain, which would mean you could eliminate every other candidate 6 from row 2. Now, when you have an open-ended AIC Type I with two freestanding endpoints that do not see each other, you know that one of those two endpoint candidates has to be true. But you don't really know anything for sure about all the other candidates in the middle of the chain. But with a continuous loop, you do know something about every single candidate in the loop. You know that either all the blue ones are true and all the yellow ones are false, or all the yellow ones are true and all the blue ones are false. All the candidates alternate true and false one way or the other. The coloring just helps us see them. This means that any other same-digit candidate that can see both a blue one and a yellow one must be false, because either the blue one or the yellow one must be true. And this is the case for every weak link in the loop. This is why the weak links in a continuous loop become effective, strong links. Now, these continuous loops are very rare, and when you're making chains, you'll probably be able to make a continuous loop about 5% of the time. But just know that whenever you are able to do it, there are a lot of candidate eliminations because all the weak links become effective, strong links. I hope that's clear. All right, so now let's take a look at some real examples of XY chains in some real puzzles. Now, some applications have a filter that will highlight all the by value cells like this. And if you have access to this feature, you might want to turn it on whenever you are trying to construct an XY wing or an XY chain. And if you don't have this feature, then you might want to manually color all the by value cells if possible, so that they will easily stand out. But if you cannot do either of those things, don't worry, it is not the end of the world, because by value cells are not that hard to see even without coloring of any kind. But you do have to have all the possible candidates filled in, either automatically by your app or by hand, or you will probably not be able to see these. Here we have an XY chain made up of 4 by value cells, and here are the 2 endpoint cells. And the endpoint candidates will be candidate 3. Now, as time goes on, you may come up with your own method of finding and constructing these things, and that's great. But here is how I do it. If I were looking to start an XY chain on this by value cell here in row 5, column 8, with the 3 as my potential endpoint, I would first say to myself in my mind, on 3. And then because 6 is the other candidate, I would look for other by value cells containing a 6 that can see the first cell. Then I just keep looking for more by value cells, stringing them together one by one, knowing that the other endpoint cell has to contain a 3, but the link must come into that endpoint cell on the other candidate like this. Okay, so let's start on this 3, and then there's a strong link to that 6, and then there's a weak link to that 6, strong to the 7, weak to this 7, strong to that 1, weak to this 1, and finally strong to the 3. Now remember, the strong links are always going to be within the cells, and the weak links are going to be between the cells. So each 2 by value cells that you link together must share a common candidate. Here in row 5, these share a 6, and then in block 4, these share a 7, and then in column 1, these share a 1. And those are the weak links. So now we know that the endpoints are these 2 3s, so any 3 that can see both of those 3s is going to be false, and there's only one, and it's right there. Now this cell can see both endpoints, but there is no candidate 3 in there. But there could be, and that wouldn't disrupt any of the strong links, so there could be a 3 in that cell, but in this case there's not, and there's only 1 3 to eliminate in row 8, column 8. So let's draw the chain, and we know we don't need to draw the links in the cells because those are going to be all strong links, so we only need to draw the weak links. So there's a weak link from that 6 to that 6, there's a weak link from that 7 to that 7, and then there's a weak link from this 1 to this other one down here, which I'm going to have to draw like that. And then a strong link to the 3. So those two 3s, the blue one up here and the yellow one down here, are strongly linked by an effective strong link, and that means you can eliminate this 3 in row 8, column 8. All right, let's go to the next one. All right, here we have another XY chain made up of 4 by-value cells, and this time let's not use the filter. So here are the 2 endpoint cells, and the 2 endpoint candidates will be candidate 2. So let's start here in row 6, column 7, and we have a strong link to the 1, and then we have a weak link to this 1, strong to the 3, weak to this 3, strong to the 5, and then weak to this 5, passing the 2, and then coming back on a strong link to the 2. So the 2s are the endpoints. The blue 2 and the yellow 2 are the 2 endpoints of our chain. And as it turns out, there are 2 candidate 2s that can see both of those endpoints, and they are here and here, and they can both be eliminated as false. So let's draw those weak links. So starting on the 2 in row 6, column 7, we have a strong link to that 1, and then we have a weak link to that 1, and then a strong to the 3, a weak link down to this 3, strong to the 5, and then a weak link down to this 5, passing the 2, and then finally a strong link to that yellow 2. So those are the 2 endpoints of the chain, those 2 2s, which means you could eliminate those 2 red colored 2s. All right, let's go to the next one. Okay, once again, we've got an XY chain made up of 4 by-value cells, and let's turn on the filter this time, and we're going to start in this cell, and we're going to end in this cell. And our endpoint candidates are the candidate 1s. So we're going to start up on this cell in row 2, column 8, and we're going to say on 1, we have a strong link to the 7, and then a weak link to this 7, strong to the 3, weak to the 3, strong to the 9, weak to that 9, and finally strong to the 1. So we start on the 1 and end on the 1. And this means any other candidate 1 that can see both of those 1s will be false, and in this puzzle we've got 4. There's one here, 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 and here. Those 4 1s are false and can be eliminated. All right, let's go to the next one. All right, this time our chain is made up of 5 by-value cells, and let's turn on the filter for by-value cells, and we're going to start on this cell and end on this cell. And our 2 endpoint candidates will be candidate 7. So let's start on this candidate 7 in row 7, column 6, and that's a strong link to the 4, and then a weak link to this 4, strong to the 3, weak to this 3, strong to the 2, weak to this 2, strong to that 3, weak to that 3, and strong to this 9, weak to this 9, and finally strong to that 7. So the blue 7 down here in row 7 and the yellow 7 in row 3 are the 2 endpoints of the chain. And because those 2 7s lie in 2 different chutes, there can be a maximum of 2 possible eliminations, and there's one in each of those cells. There's one here and one here. Those are the only 2 cells that can see both of the endpoints, and they both contain a 7. So both of those 7s are false, and let's draw the weak links. So starting on the 7 in row 7, column 6, we have a strong link to that 4, and then a weak link to that 4, and then a strong link to that 3, and then we have a weak link to this 3, and then a strong link to the 2, a weak link to that 2, and then strong to that 3, and then a weak link up to this 3, and then strong to the 9, and then weak down to this 9, and then finally strong to the 7. So the 2 7s are the 2 endpoints, and those 2 red-colored 7s can see both the endpoints, and they can both be eliminated as false. All right, let's go to the next one. Okay, once again, we've got an XY chain made up of 5 by-value cells, and let's not use the filters this time. Here are the 2 endpoint cells, and the endpoint candidates will be candidate 4. So let's start on this 4 here in row 4, column 8, and that's a strong link to the 9, weak to that 9, strong to the 5, weak to the 5, strong to the 9, weak to the 9, strong to the 2, weak down to this 2, and finally strong to that 4. So the 2 4s are the 2 endpoints. And because they lie in the same chute, there can be a maximum of 6 eliminations, but here there are only 4. Here, 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 and here. And these two cells already contain an 8 and a 1, so there's nothing to be done there. So you can eliminate these 4 candidate 4s. Okay, let's go to the next one. All right, here in this puzzle we have an XY chain made up of 9 by-value cells. So you're going to have to watch very carefully. Let's turn on the filter for by-value cells. And our 2 endpoint cells are here and here, again on candidate 4. So we're going to start on this candidate 4 in row 1, column 1, and then that's strong to the 9, weak to this 9, strong to the 7, weak to this 7, strong to the 4, weak to this 4, strong to the 8, weak to this 8, strong to the 1, weak to this 1, strong to that 9, weak to this 9, strong to the 1, weak to the 1, strong to this 9, weak to this 9, and finally strong to that 4. So those 2 4s in row 1, column 1, and row 2, column 6 are the 2 endpoints of the chain. And there are 2 candidate 4s that can see both the endpoints, and they are here and here. So those 2 4s can be eliminated as false. All right, I hope everyone followed that. Let's go to the next one. All right, this time our XY chain has 8 by-value cells. And don't forget, the number of by-value cells can be odd or even. Because if there are 8 by-value cells, there are going to be 8 strong links, and then there will be 7 weak links connecting them, for a total of 15 links, which will give you your odd number of links. And AIC Type I will always have an odd number of links. So there can always be any number of by-value cells. So let's turn on the filter for the BVCs. And here is our start cell, and here is our ending cell, and candidate 1 is going to be the endpoint candidate. So let's start here in row 5, column 3, and we start on this 1. There's a strong link to the 8, weak, strong, weak over to this 1, strong to the 2, weak to that 2, strong to the 9, weak down to this 9, strong to the 2, weak to the 2, strong to the 9, weak to this 9, strong to the 3, weak to this 3, and finally strong to that 1. And don't forget, when you're making those weak links between the cells, it doesn't matter if there are any other same digit candidates in that house, because you only need a weak link, so you don't even need to pay attention to that. As long as you see 2 by-value cells with a common candidate, you can always make a weak link between those 2 candidates. So in this diagram, the 2 1s in these colored cells are our endpoints, and there are 3 candidate 1s that can see both of them, and there's 1 here, 1 here, and 1 here. They are all false. Okay, let's do another one. All right, here in this puzzle, we have an XY chain made up of 7 by-value cells. So there are the by-value cells, and our starting cell is here, and our ending cell is here, and candidate 9 in those 2 cells will be our start and end points. And remember, you could start on either one of those 9s and it would still work, but let's start on this one up here in row 2, column 7. And we've got a strong link to the 4, a weak link to this 4, strong to the 7, weak to the 7, strong to the 8, weak to this 8, strong to that 7, weak to the 7, strong to the 9, weak to this 9, strong to the 1, weak to this 1, and finally strong to the 9. Now remember, the candidate that you enter the final cell with a weak link cannot be the endpoint. So we entered that cell on a candidate 1. There's a weak link between those 2 1s, but the final link has to be a strong link, and it has to be to a candidate that's the same as the 1 in the start cell. So here the 2 endpoints are those 2 9s, and in this diagram there are 3 9s that can see both of those endpoints, and they are here, here, and here. Those are all false. Okay, let's do one more and then we'll wrap it up. So of course I saved the best one for last, so let's turn on the filter for BVCs, and there they are. And as it turns out, we have an XY chain here made up of 9 BVCs. But what you're going to see is that no matter which one of those 9 BVCs we start on, the endpoints are going to wind up in the same house, so that means we have a continuous loop, because you can make a weak link between those 2 endpoints no matter where you start. So here are the 9 cells. We've got one here, 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 and here. So let's mark the chain. So we could start anywhere, but let's start on this 7 here in row 2, column 8, and there's a strong link to the 9, then weak, strong, 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 and then you can make a weak link between those two 7s to complete the loop. So now what this means, as I showed you in the earlier example, is that all the weak links become effective strong links because you could make an XY chain starting on any one of those cells. So first let's mark the eliminations and then I'll draw the chain. So there was a weak link between these two 9s in column 8, so that 9 is false and that 9 is false. And then there was a weak link between these two 4s in the same column, so that 4 is false. Then there was a weak link between these two 3s in row 8, so that 3 is false. Then there was a weak link between the two 4s in block 8, so those two 4s are false because they lie within that same block. Now notice that these two 4s over in row 8, column 1 and 2, they can see this naked pair of 4 and 3 in row 8, so they are both false. And they can also see both a yellow 4 and a blue 4, so they are false, but that's unrelated to the loop, so we'll leave those out for now. Then there was a weak link between these two 6s in column 6, so that 6 is false. Then there was a weak link between these two 2s in column 6, so that 2 is false and that 2 is false. Then there was a weak link between the two 5s in column 6, so that 5 is false. And those two 5s also lie within block 2, so this 5 is false because it lies in block 2. Then there was a weak link between these two 4s in row 2, so those two 4s are false. And those two 4s also lie within block 2, so this 4 is also false. And then finally, there was a weak link between these two 7s in row 2, so that 7 is false and that 7 is false. So when you find a continuous loop, you have hit the jackpot. It's like winning the lottery, or if you're playing poker, it's like getting a straight flush. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 eliminations because of that continuous loop. So now I'm going to superimpose the chain so you can see it. And because there are 9 by-value cells that make up this loop, that means there are 9 strong links within the cells and 9 weak links between the cells. So there are 18 links and 18 candidates, an even number of links and an even number of candidates or nodes. And because the loop is continuous, you can start on any one of those 18 candidates and move in either direction, and it's going to give you the exact same result. So remember, either all the yellow ones are true and all the blue ones are false, or all the blue ones are true and all the yellow ones are false. So any same-digit candidate that can see both a blue one and a yellow one is going to be false, and that's why those weak links become effective, strong links. So you should try to construct a continuous loop whenever you can, which I said is very rare, but they are probably the most beautiful technique of all. All right, so that's going to do it for today, so let's go back outside and finish up. Thanks for watching. Okay, so those are XY chains. When you have a lot of by-value cells left in a puzzle, there is a high probability that you will be able to construct some XY wings or XY chains. Just look for BVCs that contain one common candidate and that can also see each other. In the next lesson, video number 29, we will learn about remote pairs, which are simply XY chains composed of identical by-value cells, except that they can branch off in multiple directions. Remote pairs can sometimes look more like a network than a regular chain. With remote pairs, the benefits are compounded, so you should definitely add this powerful technique to your solving arsenal, and I will look forward to seeing you for that tutorial. Until then, be well and be happy.